Inspired by Amma's vision of sustainable development, Amrita Nano Solar took up the challenge of establishing a storage integrated solar module lab where initially crystalline solar modules are made. Amrita Nano Solar actively pursues sustainable, low-cost option for power generation. This research lab makes solar modules for the programs of Mada Amadandamayi Much. This lab is equipped with state-of-the-art equipment from around the world for each process in the assembly line. Amrita Nano Solar solar modules comply with international standards for safety and performance.
We begin the manufacturing process with cell testing, which is a simple step towards quality assurance. In this step, we test each and every cell that goes into the making of solar module. After cell testing, we move on to tabbing, where we solder interconnecting ribbons onto the cell. This is a manual process performed by our trained technicians.
The tabbed cells are serially interconnected to form what we now call the string. There are 10 solar cells in a single string. Cells are serially stringed for the purpose of obtaining the desired power output. 6 of the strings are together moved to the layup table, where we stack all the raw materials to form a panel sandwich. This particular process is called layup and involves the placing of strings between EVA sheets, glass and back sheet. The strings are serially interconnected and the output leads are drawn out.
Cells, being very brittle, need to be tested for cracks, which is done by placing the panel sandwich in an EL tester. Micro cracks can affect the lifespan of solar panels and need to be detected and replaced. EL tester takes a thermal image of the panel and highlights the cracks if any. The tested panels are now fed to a laminator, which will be preheated to 150-degree temperature. At a time, we can load 2 different panels for lamination. The laminator will vacuumize this panel area. EVA will melt at this temperature and the panel sandwiches are pressed to form a single solid panel. The laminated solar panels are trimmed manually using hot knife and its edges are covered with a silicone double-sided tape. It is then inserted into an aluminium frame and crimped with a framing machine.
We will now fix the panels with a junction box using silicone sealant. The framed panels are then tested using a solar sun simulator. This step ensures that the framed panels meet all the desired parameters like wattage and efficiency.
We now have a finished solar module that is ready for installation and power generation. Initially, we are manufacturing 250 watt panels only. The production process was started in May 2015 and the plant currently has a capacity of 2 megawatt per annum.
We have been able to manufacture 500 kilowatt of solar modules in a very short span of 3 months, out of which a majority is already in the deployment stage. We have powered one village with a solar lighting, and I am sure many more projects are lined up by the solar modules we make in this facility. We are deeply satisfied that we are in sync with the vision with which the entire endeavor was started.